All right, so Callista, I'm going to help you on this worksheet 1.6. And I'm going to be honest with you. Now, that's a pile of clothes on my bed back there. My daughter did my laundry for me, but that's stuff I have to hang up. And I got a little one that's fixing to come out of the bathroom behind me. She's fixing to bust through those doors and run in there. But it doesn't matter. Okay, so I'm going to help you with this worksheet. But I have to tell you, this really confuses me. I really have to think about this because this is, my brain doesn't think like this, and it's kind of hard. But I have good news for you and me both. This is not something, I looked at the test that you'll be taking for test 1. I don't know when. It'll be a while, several weeks from now. And it didn't look like any of this is on the test. I think there's one question on the quiz that you're going to take in a few days. That there may be one question on it that's real easy, and I think you should be able to get it. But anyway, so what I'm going to do is I'm going to try to explain it to you a little bit. I've taken a few minutes to study it again myself, and then I'm going to help you with some of that worksheet. Wave hi to Callista. Can you close the door, Maddie? Oh my gracious. I'm recording. Do you mind? Anyway, okay, so let's see here. We're going to look in your book then on, go ahead and look at the bottom of page 31. We'll read this and try to figure this out, okay? Now, before we move on, we're going to take one more look at the concept of place value. It's this pretty important concept. While I'm sure you're quite familiar with one current place value system, which is what we use, did you realize computers use place value systems based on value besides 10? And that's what's known as the binary place value system. Exploring this system along with the hexadecimal place value system is not only cool, I don't think it's cool, but they do, but it can also help provide an even firmer grasp of the decimal place value system. Okay, and that is true. It can help us understand our place value system a little bit better. All right, so turn the page. All right, so at the top, it's going over, the very top is just showing you, it's like physically showing you our place value system using the number 42. Now, you know that when we go from one place value to the next in our decimal system, say we go from the ones place to the tens place, we do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And when we go ready to put the 10th one in there, you can't, because you can't put 2 digits in one spot. So you can only leave 9 and you carry over 1 to the next one. And then when that fills up with 9, you're ready to put the 10th one in there, you got to fill it up. Kind of like what on the abacus, it kind of showed us. Every time you filled up one line with 10, you got to scoot it over and rename whichever way you're doing. All right, so this shows us that in 42, each place has 10 places. So in our decimal system, now you might say, well, each place can't, it only has 9. No, it has 10 because 0 is counted. So in that box, you see the box where it says 42. I'm on the top of page 32. All right, and there's 2 boxes, it says 42. In the ones place, there's 0 through 9. That's 10. And then in the tens place, 0 through 9. And remember, every time you get to that 10th one, you got to go to the next. Okay. The binary place value system, one that computers use, does the exact same thing, except each place can only hold 2. Remember, binary, bi means 2. Bicycle, bifold, whatever. Bi means 2. All right, so let's look at the binary system. So this is something computers use. Frankly, to be honest with you, I can make these videos and I can get online, but I don't know how computers work. And that does not interest me the least bit. And so I'm not doing this for computer purposes. This is just kind of a thinking thing. If you don't get it, no worries. This is not something you have to master to get through. It is not. This is kind of an extra thing. All right, so in a binary system, instead of allowing 10 values, 0 through 9, in one place, they only allow 2, 0 and 1. And then when you're ready for to put the number 2 in there, which would actually be the third number, you got to go to the next section and the next section. So you can imagine how quickly a binary number can get large. All right, so let's look where it says in binary, the number 10 represents one set of 2 and 0 sets of 1 or 2. So here we go. Now they've made their boxes just like they did up here. So in that first box where it says ones, it can only hold 2 numbers, binary, okay, 0 and 1. And in the number 10, the binary number 10, there's 0 of those. All right, now look at the next box. It can only hold 0 and 1, but we have 1 of those because remember the number we're working with is the binary 10. So you put 1 there on top of that because there's 1 2s. To make things clearer, take a look at the first 4 places or containers for both systems. So at the very bottom of page 32, here's our decimal base 10. This is ours. You've got ones, tens, hundreds, thousands. Each one of those has 10 places, 0 through 9. Okay, top of page 33. Okay, instead of having ones, tens, hundreds, thousands, because remember our decimal system is based on tens. Okay, in the binary it's based on 2s. So you've got 1s, 2s, 4s, 8s. Okay, now let's take a look at how this plays out with a few numbers. All right, example. Find the decimal place value of the binary number 1010 or 1010. I think is how you're supposed to say that. So you're going to write your boxes. When I do this, I have to put boxes of some sort, and I'm fixing to put on the screen kind of what I do, and it's a little bit more helpful, kind of gives you a better idea. All right, so you're going to have your 4 boxes, and you're going to label them 1s, 2s, 4s, and 8s. There's an easier way to label that, and I'll show you that in just a second. And then you're going to put your binary digits on top of the boxes where they go, 1, 0, 1, 0. Now, look right below there. It says 1 set of 8. Now, we're starting in the 8s. Not eighths, the 8s. All right, so we go 1 set, there's 1 set, because see there's a 1 on top of there. There's 1 set of 8, 1 times 8 is 8. Now in the 4s, there's 0 sets of 4, so that's 0. In the 2s, there's 1 set of 2s, so that's 2. And then in the 1s, there's 0 of those, so it's 2. So you add that up, and you get 10. So 1010 in binary is the same as the regular decimal number 10. All right. Now we're going to do one more example before I show you something else. So we're going to find the binary number 1111. There's a particular way you're supposed to say those numbers, and I can't remember how you do it, but it's not necessary. So again, we're going to lay out our little things here, our little boxes, and then we're going to put the numbers on top of where they go. Okay, and then we're just going to multiply. 1 set of 8 is 8, 1 times 8. 1 set of 4 is 4. 1 set of 2 is 2, and 1 set of 1 is 1. So you add all those up, 8 plus 4 plus 2 plus 1, you get 15. So in binary, the binary number 1111 is the same as the decimal number 15. Now, you might ask, why is this necessary? No, I wish I knew, but nonetheless. Okay, so I'm going to put, before we go to the next section, I'm going to put something on the screen. It's kind of a little bit easier, perhaps, might help you see it a little bit more clearly. So let me go ahead and put that on the screen. Okay. So I'm sorry about the scribble writing on here, but I have to do this with my mouse, and that's hard to do. Now, don't look at any of these 2's down here. Right now, we're just looking at this right here. I'm just going to try to explain to you something. Okay, I'm not sure if you've done exponents, if you've studied exponents yet. But exponents are an easy way of multiplying a number times itself however many times. So if you take, let's just take this number. 10, we say 10 to the 4th power. What that means is 10 times 10 times 10 times 10. Now it doesn't mean 40 because that would be 10 times 4. We're doing 10 times 10 times 10 times 10, which equals 10,000. Now, anytime, okay, tell him I'm recording a class. Please go in there. I'm sorry for the interruptions. So anytime you have a number with the exponent, these numbers here are called exponents. Anytime you have a number with an exponent of 0, that means 10 to the 0 power. That means 1. That just means 10 by itself, just 10. All right, anytime you have a number with an exponent of 1, that's that number. Okay? If you have it by 2, then what you do is you take this number and you multiply this number twice. So 10 times 10 is 100. 10 to the 3rd power, we say, is 1,000. 10 to the 4th power is 10,000. And 10 to the 5th power is 100,000. 10 to the 6th power is a million. And on and on and on. We can go as far up as however far you can count. Now, I've put this number here. It's kind of far out, but it's 8,466,123. And I just wanted to show you kind of how this goes. This is our decimal system, okay? We're not talking anything binary right now. All right, so when you have 3 times 10 to the 0 power, that's basically saying 3 times 1, okay? Which means you just have 3 ones, right? Okay. If you have 2 10s, because remember 10 to the 1st is just 10, you have 2, that means you have 20. And this is 23, right? All right, here we have 1 times 10 to the 2nd. Well, 10 to the 2nd is 100, right? And you just have one of those, so it's 100. Okay, here we have 10 to the 3rd, which is 1,000, but you have 6 of those. So that would be 6,000. See, that's the place it's in, and that's what it's worth, is 6,000. Each one of these is in the place what it's worth. This would be worth 60,000. 10 to the 4th, that's this place value. This place value makes this worth 400,000, and this makes this worth 8 million. Okay, that's our regular place value. When we use binary, and we're going to do this in a minute, we're going to study hexadecimal as well, and it's no different, it's just different numbers. Just like we do all of base or place values of 10, well, when you do binary, you have place values of 2, because remember binary means 2. So you can do the same thing. 2 to the 0, again, is 1. Any number with an exponent of 0 is 1. All right, 2 to the 1st power is 2. 2 to the 2nd power is 4. 2 to the 3rd power is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. And 2 to the 6th power is 128, and on it goes. All right, now this here doesn't really have any meaning as to what any of this means. I'm just trying to show you what ours is laid out and what binary would be laid out. Okay? Now, what I do usually when I'm trying to figure this out myself, again, I can't do this kind of stuff in my mind. I have to write every step down, every part of the algorithm I have to do, or I won't figure it out. When I'm trying to do either hexadecimal or binary or whatever I'm doing, then I'm going to, which is like never, but anyway, I have had to do it a few times in school. So I would just say, okay, well, I'm using binary. The problem says binary. So on my scratch paper, I would just write 2 to the 0, 2 to the 1st, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, however far I needed to go. Sometimes you might have to go further, but probably not. And then whatever number it says, figure out what in binary what this number is. And then what you do is you just put the number that it gives you over the place value of what it is. And then you just take that number and multiply it by the place value. And I know that probably doesn't make too much sense right now, and that's okay. All right, so I'm going to go ahead and get off of here. I don't know if this makes any sense to you. If you want to pause it and jot this down, go right ahead. I don't know if it'll help, but it might. So I'm going to go ahead and I'm going to stop this one, and I'm going to go back to the screen because I'm going to help you with something else. All right, I have no idea if that helped you, but I hope it helped explain a little bit. Remember, don't get overwhelmed by this. This is a whole lot of information, and you are not going to be tested over it. It's not going to be pass or fail or whatever. It's just kind of something to kind of wrap your mind around and kind of get you thinking a little bit. All right, so let's turn the page to page 34. All right, now at the top it has this gray box that talks about computer circuits. Be my guest to read that if you'd like to. I did read it and it makes some sense, but just some. All right, so then it talks about it says making computer talk more concise. Now it's talking about hexadecimal. This gets a little bit more intimidating, I guess you could say, but we're not really, I don't think we're even using hexadecimal in anything that we're doing, but we'll go over it just nonetheless. All right, so in hexadecimal, you have to start adding letters. I know it. I hate adding letters to numbers, but nonetheless. Now, look right here where it says base 16 hexadecimal system. So you have 16 symbols. Remember, if it's hexadecimal, remember what hexa means. So 0 through 9. And then because we can't have two digits of any kind in one spot, we start with letters. So after 9, you start with A, and that's actually 10. B is 11, and it tells you right there. C represents 12. D represents 13. E and F. Okay. So that means, so now look at the very bottom of page 34. So each of these boxes has 0 through 15, or F. Okay? So in a hexadecimal system, each place has the place value is worth 16 places in each, in hexadecimal. Remember, 0 through 15 is 16 digits. All right? So you have the ones, because that's 16 to the 0 power. And then you have the 16s, which would be 16 to the first power. Then you have 256s, because that would be 16 to the second power, and if you multiply 16 times 16, you get 256. So that's your third. And then you go to the fourth one, and that would be 16 to the third power, and that's 4,096. So if you multiply 16 times 16 times 16 to the third power, you're going to get 4,096. Okay, and each one, that's what those are worth. Now, look at the top of page 35. Here's an example of a decimal value, which is our numbers. Decimal numbers are ours. That's what we call them, or Arabic. So find the decimal value of the hexadecimal number 4B0. All right, so here's what they did. They wrote they put 3 boxes because there's only 3 digits up there. That's all they have to do. And they were reminded, this is the ones, this is the 16s. What I would do is I'd draw my boxes, but inside those boxes I would put 16 to the 0. In the second box, the middle one, I'd put 16 to the first. And then I'd put 16 to the second. Okay? And you could even put, what it's worth below there. In the ones, you'd just put, it's worth 1. And then in the 16s, you'd put 16 to the first 16. And then 256s, you could put 6. I'll put this on the board and let you see it rather than me just tell you. All right, so then they're going to put 4B0 over those boxes. And look right below there. Now, where the 4 is, that space is worth 256. So you multiply 4 sets times 256 and you get 1,024. Okay. Now you understand why I do my lessons in the morning time. All right, then we're going to move to the B. Remember, B represents 11. So 11 sets of 16 is 11 times 16. You get 176. And then you have 0 sets of 1, so that's 0. So add those together, 1,024 plus 176. You get, in the decimal number, 1,200. So 4B0 in hexadecimal is the same number as 1,200 in our digits. Okay? All right, so right quick, let me put on the board what I would do if I were figuring this, and then we'll go over a part of your worksheet. Okay, I should have already done this, but I'm going to go ahead and I'm going to erase this. I hope I can do this correctly because sometimes I get messed up on it. So let me erase this. Woo, we got some stragglers here. Got a little bit there. Let's see about this. All right, and then, okay, and then we're gonna, let's see here. No, not that one. That one won't work. get these out of here. All right, Maddie, don't lock the door. All right, so let me go ahead and get my pen here. Get it up a little bit. No, I don't think I want that. Okay. All right, so if it was me, remember the number they were doing. They were doing 4B, remember that's 11, and then 0. And it wanted you to find out what this would be in decimal form, this hexadecimal number, what this would be in decimal form. Okay, they said hexadecimal. We automatically know that we're talking 16s. So I would say, okay, 16 to the 0, which is 1. There's my first box. I'm not leaving myself much room. And then 16 to the first would be 16. And this is literally what I would do on my paper if I were figuring this out. And then I'd go 16 to the second. Like I said, if you multiply 16 times 16, you're going to get 256. Make this box. All right. Then what you would do, once you get all that, then you just take these numbers and put them over where they go. You might say, well, how do you know where they go? It's just in the order in which they are. Whatever order they are, that's where they go. Okay. So then you say, okay, so I have 4 of these, and each one's worth 256. So it's going to be 256 times 4, which what we said was 1,024. That's in our book. This is the same one that's in our book on page 35. All right. And then we multiplied, remember this is 11 times 16. And that comes out to be 176. And then you have 0 of these, so that's 0. Then you just add these up. And remember, in our book it said it was 1,200 or 1,200 in the decimal value system. Make sense? If you want to, you can write that down. But this is the way I always do it. And I don't do it often, but I have, like I said, I've had to teach it a few times, but not very often. All right, so we're going to go ahead and I think I have your worksheet here, right here. There we go. No, that's not the one. It is the worksheet, but I wanted this one right here. There we go. All right, so this is your worksheet. So I wanted to kind of help you with this a little bit. So on number 1, where it says binary, remember these are the 2's. The following numbers are written in binary. Translate them into the decimal system. Remember, decimal system means our number system, by filling in the blanks. Okay, so 1100 or 1100. Okay, we're doing binary, remember, so we're going to go, this would be 2 to the 0, 2 to the first, 2 to the second, and 2 to the fourth. And 1s, 2s, 4s, and 8s is what that equals. All right, so on this, then we're going to put our numbers at the top. Okay, how many sets of 8 do we have? 1. Okay, so 1 then times 8 is 8. That's this. All right, then we have 1 set of 4. So 1 times 4 is 4. I don't know if you can hear that, but my daughter's playing her violin. If you hear something, it's her playing. She plays very well. All right, then we're going to go with our 2's, and there's 0. So that's just 0 times 2, which of course is 0. And then here you have 0 sets of 1, which is 0, which is 0. And we just add our numbers up. So we have 12. 8 plus 4 is 12. So 1100 in binary is the same as 12 in our regular decimal system. Does that make sense? Okay, and you can copy all these answers down because I'm not grading this. In fact, I don't even need to see it now since I'm going over it with you. I did not, I don't think I have your other pages on here. Okay, yeah. All right, so now this is going over 16s. This is the hexadecimal, okay? So this is 10000, 5 zeros. And this is the hexadecimal. I want you to find hexadecimal. No, I'm sorry, binary. I'm sorry, it didn't say this is binary, and I know that because there's 2 in each. I'm sorry. Okay, so here we're going to put our ones, which is that's 2 times, or 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the fourth, 2 to the fifth. And if you multiply all those 2's together, that's what you're going to get. All right, so, and then we're going to put our numbers where they go. And so you have one set of 16, which equals 16. The rest of these are 0. You have 0 sets of all these. So all these are going to be 0. So 1, 0, 0, 0, 0 in binary is the same as 16 in the decimal system. Okay? And then you have this one here. Same thing. You're just going to put your 1 here. One set of 16 would be 16. You have 0 in everything else except your 4s. You have one set of that, so that'd be 4 there. 1 times 4. And then you're just going to add them up. So you'd have 1, 0, 1, 0, 0 in binary, the same as 20 in the decimal system. I'm recording the class. I need you to keep it quiet, okay? All right. I hope that makes sense. Now let me check your worksheet out. All right. On the second page of your worksheet, on page 34 of worksheet 1.6, on the back it says the hexadecimal system, which is base 16. We call that base 16, or binary could also be called base 2, or and it can be any number. If you have 12, you would call it base 12, and each set, each place value would have 12 digits. You could do base 50, and each place value would have 50 digits. Base 5, each place value would have 5 digits. All right, so, and it tells you at the very top, the hexadecimal system, base 16, tells you very top what those letters represent, because remember, you got to keep, you got to keep going. And see, that's another thing. If you go higher, like if you have, say, base 50, then you're going to have lots of letters, because when you get all the way to Z, you start back over AA, BB, CC. And so it could go it could be crazy if you did it that high, but I don't think that will happen. So let's do this. I did not scan either one of your other worksheets or the other pages of your worksheet. If you feel like you understand, you can try to do number 2, where it's the hexadecimal number. Don't get confused about the color. That just kind of goes with computer stuff. You will not have to know that. You don't have to worry about the colors, but RGB is a color system that's used by computers, red, green, blue. And there's a scale that represents how, dark the colors are, yada, yada, yada. I don't even get it myself. But if you want to try and find these numbers in here on the base 16, go right ahead. Like I said, I'm not grading it. It's not really even anything you're going to be graded on, even on a test. I do, however, want you to make sure and start on number 3 on page 35, and you'll want to finish the whole worksheet after that, 3 to 7. There's some on the back with the abacus. All right, so I hope I did not just confuse you a whole lot more. If I did, I apologize. So just let me know. Michelle, I am just not getting it. And if that's the case, then we'll just move on, because like I said, this is not a skill you must have. If you get it, that's great, great, great. Anyway, just let me know. I sure would appreciate it. Okay, I think that's it. You don't have to see my face anymore, so I will see you soon.